Aim for this experiment is to draw the reverse characteristic of zener diode to study its voltage regulation characteristic using a variable load. So what is a zener diode? A zener diode is a silicon semiconductor device that permits current to flow in either a forward direction or reverse direction. Diode consists of a special heavily doped PN junction designed to conduct in reverse direction when a certain specific voltage is reached. The reverse characteristic of a zener diode. When a reverse voltage is applied to a zener diode, initially a small reverse saturation current to flow across the diode. This current due to thermally generated minority carriers. As the reverse voltage is increased at a certain value of reverse voltage, reverse current increases drastically and sharply. This is an indication that the breakdown has occurred. We call this voltage as breakdown voltage or zener voltage, and it is denoted by Vz. And the zener diode as a voltage regulator. When forward bias, it behaves like a single normal diode, but when the reverse voltage is applied to it, voltage remains constant for a wide range of current. Due to this feature, it is used as a voltage regulator in DC circuit. Component required in this experiment is zener diode kit, resistance box, and some connecting wires. The zener diode functions as an ordinary diode when it is forward biased. This is specially designed device to operate in the reverse bias. When it is in reverse breakdown region, zener voltage remains almost constant irrespective of the current through it. A series resistor is used to limit the zener current below its maximum current rating. Value must be properly selected to fulfill the following condition requirement. When the input voltage increases, Vi remains the same and increases. Similarly, if input voltage decreases, remains the same and decreases. But if falls lower than the minimum zener current, enough to keep the zener in the breakdown region, regulation will cease, output voltage decreases. Low input voltage can cause the regulator fail to regulate. Series resistance should be selected between and which are given by this expression. So this is an apparatus for this experiment. First, for the line regulation, set the zener voltage, set the series resistance value, set the load resistance value, vary DC voltage. Voltmeter is placed parallel to load resistor and ammeter series with the series resistor. Choose appropriate DC voltage such that zener diode is on. Now note the voltmeter and ammeter reading various DC voltage. Note the load current, zener current, output voltage, and calculate the voltage regulation. And similarly for the load regulation, set DC voltage, set the series resistance value, vary the load resistance. Voltmeter is placed parallel to load resistor and ammeter series with the series resistor. Choose load resistance in such a manner such that the zener diode is on. Now note the voltmeter and ammeter reading for various load resistance. Increase the load resistance. Note the load current, zener current, and output voltage. And calculate the voltage regulation. Last, for the zener characteristic, first state the diode and set the rheostat to 1 ohm. Adjusting the rheostat, voltmeter reading is increased from 0 and in each time note the corresponding reading in milliammeter. Take the reading and note voltmeter reading across zener diode, ammeter reading. So this is a circuit diagram for the experiment. The least count of input is 0.5 volt. The least count of output is 0.2 volt. And we have taken the fixed load resistance 1000 ohm and the variation in output voltage and input voltage is given in the table. As we can see, the output voltage is 8 volt and we study variation in output voltage and load resistance. We have put the constant input voltage to in volt. Here we can also see that output voltage is 8 volt. By plotting the graph, percentage line regulation is equals to 3.3%. So the zener or breakdown voltage of a given zener diode is 8 volt. The percentage line regulation is 3.3%.